Hello friends, welcome back. Today in this video we will implement function code number 4, analog input registers, and also we will implement function code number 1 and 2. These two function codes are related to discrete signals, that is on off signals. So let's start with the backup of our previous project and we'll implement in the previous project. Open this file and also rename it in the Cube IDE software. Don't worry if all the files does not get changes. The major files which are required at the backend gets renamed successfully. Now here in the main function, our intention is to make this C function MB process registers as a modular function for function code number 3 as well as function code number 4. Means we need not rewrite the whole code for function code number 4. So with few changes like passing the arguments, like for function code number 3 we have to read from holding registers array and write to data in. So we'll pass first argument as the holding registers, that is the source array. Okay, and also we will calculate the size of holding registers array, because as per your project it might be different. So reg size, I'll use this variable for calculating the size of holding registers array. So using the size of function we calculated the size of holding registers. Let's go into this MB process registers to see for any further changes. Like we updated the argument list, so we need to update of course here also. So it will be unsigned integer. I'll use the pointer function input array, and the second argument is the size, so unsigned integer input array size. I'll save it. Now here is the first condition. We are actually calculating the size of data in array. Data in array, we know that it is 256 bytes. As per the Modbus RTU over serial lines, the maximum size of the packet can be up, the PDU can be 256 bytes. So it is actually 256 minus 5u. That is 251 unsigned. So instead of calculating, we can simply put the constant value. Okay. Now here in the register count, whether it is function code number 3 or function code number 4, the master can request a maximum of 125 registers. The end address, now here we were calculating the size of the holding registers array. So now it is in our arguments, so we will do some changes. It is the in array size minus 1. Our end address should lie within the size maximum size minus 1. In the append data, instead of holding registers we will pass the input registers which we received as the first argument. Now in the CRC I forgot to include the slave ID as the in the CRC calculation. So I have to include the starting 3 bytes, that is the slave ID, function code number, and also the number of bytes. So these 3 bytes also should be included in the CRC correction calculation. Now this, due to that argument change, here we have some more changes to be done, and the final response frame size is affected with that. Now this is done. Now the final thing to be done is to declare this modified function in the main.h in the function declarations. So I'll update it. Let's build the project and see if we have any errors. We do not have any errors. The warnings are there. Let's see, the warnings are related to the holding register array, so no problem. Now we will update the same for function code number 4. So I copied that switch statement which was for function code number 3 and I am using it for function code number 4. Now instead of holding registers, I will pass here input registers. I will declare one input registers variable array and also recalculate the input register size. So I declared the input registers variable array, just copying the holding register and renamed it to input registers. I'll include the array comments. Now I'll build the project again. So we have 6 warnings now. They are related to these array variables only, so no problem. I will test our code directly. I'll put it in run mode. So once downloaded, I'll open the application. I set it up for function code number 4. I am reading the 30,001 first register of function code number 4 and I am reading 6 registers. So let's click on send button. We received some data. Let's verify it with our data, and the Modbus master is interpreting the received data as unsigned integer. So we'll check it with our input register array. Here 30,001 register means the address 0, that is index number 0, and also 6 registers. So from 0, 1, 2, 3, 4, 5. So they are equal. Now in this way we implemented the input register also. Now we will concentrate on the other two function codes, that is function code number 1 and function code number 2. For function code number 1 and 2, for discrete simply, we are storing the data in character array, that is each array will be worth 8 bits. This means that if suppose we create a character array worth 10 bytes, this means we have 80 bits available, means 80 discrete values are stored in that 10 bytes. So in the main function we'll start with the declaration of those arrays. So I have declared it with me, so I'll just copy it. For understanding, while debugging, I used all of them in binary format, the coils as well as discrete inputs. I'll save the file. Now in main, what I will do, I will copy the function code number 3 and use it for function code number 2. Now for processing bits, we cannot use this function MB process registers. So instead I will create one more function called MB process bits and pass the array, just like holding registers and input registers. I'll pass the respective array. So here I'll pass the discrete inputs, that is I'll copy the name, okay, and also the discrete input size. I will create it here, unsigned int. So I calculated the size of discrete inputs register and also the coils array. Now I'm just doing for the discrete inputs first. Okay, now the discrete inputs is function code number 2, MB process bits, discrete input. I am passing the discrete inputs array shown here in the tooltip, and also the size of discrete input size. Okay, now these process bits we will simply put in the MB process register. So I'll not type each and every line. We will try to understand that function during the debug session. So I pasted the process bits function in the MB process.c file. The argument list is similar to the MB process registers, that is the input array and the input array size. Here instead of input array size, okay, this is input array size. Yeah, it's correct. And also instead of the for analog values we had append values to registers. Here we have append bits to registers. So during debugging we will try to cover all these. We'll understand why we have used those two functions. And one more thing, we need to include them in the function prototypes declaration. So over here I will add them. Okay, also the process bits. So let's build the project now. Okay, we do not have any warnings. Okay, no problem. So now what we will do, we are doing it for function code number 2. So I'll set up the Modbus simulator to function code number 2 and we'll start debugging. So it is function code number 2. Function code number 2 starts from 10,000, so it is 10, and here also the offset is 10. Let's say we want to request 10 bits. Okay, 10 bits. Here we should click on 1 bit coil. Okay, now, and the data requested is in 8 bits, 8 bits unsigned. So the first, since this is 10 bits, so and we are reading the data in 8 bits unsigned integers, register number 10,001 to 10,008 will be in the first byte, and the register number 10,009 will be in the 9 and 10 will be in the second byte. So instead of waiting for the response, like for holding register, we'll first debug it. Okay, so I'll debug the code. Okay, I'll click on continue. I'll put a breakpoint just after the detection. I'll put on the switch. Okay, we'll also see whether it goes into the correct C function or not. So now, okay, let's pause it for us. Let's check. Okay, it is continuously going into the while loop because it is not receiving the data also, and the data position variable is not yet 8. So I'll click on resume and I will simply click on send. We will not wait for the response. We will first click on check the debug thing. Okay, so now here in the STM cube ID, now the program is halted at the switch statement. We will also, we are verifying the data we received. Okay, I'll adjust the windows. Okay, so now the first byte is the slave ID, second byte is the function code number, third byte and fourth byte are the number of registers. Here in this case it is, we will say number of bits requested. Sorry, the start address of the input register, that is the discrete input register, and the fourth and fifth index are the quantity. So we want to read 10 bits. Sixth and seventh are the CRC calculation. Okay, so now we'll check what how it goes. I'll click on step into, that is pressing F5. Okay, so our the case number 2 is selected. Okay, we are passing the discrete inputs and its respective size. So its size is worth 50. Okay, so it is now here in the holding registers we count the registers required. Now here we are counting the bit counts, how many bits it is requesting. So that bits we are taking it from the data in, and also out of these bits we are calculating how many bytes the slave should send. The bit count is 10, means we need to send 2 bytes, and we are checking this function as per the function Modbus protocol. So whether the bit count requested is equal to or more than 1, and also the bit count the master can request is 2000 registers, that is discrete input registers or the coils, which we'll check afterwards. So that value is maximum is 2000. Now here also we are calculating the start address, okay, as per the Modbus master request, and also we are calculating ourselves the end address. So its end address should fall one less than the size of the bits. And finally here in the data 2 we are storing the byte count. It is here 0, we will see that it goes 2. So we are now in the processing stage. So now we have processed that, okay, we will send 2 bytes to the master. Now here in 10 bits we are sending actually 2 bytes, okay, but the 2 bytes means first 8 bits will be in the first byte, and the next 2 bits will be in the second byte. This means that the remaining 6 bits of the second byte, if here in this example the second byte will be on the data in 4 is actually 0, but if there is any value, so we need to flush that. So for that we are clearing the last byte which we will send in discrete, and we are clearing that register with the value 0. Next, the usual process, we will append the bits to the register. Now to understand this function, this is very much critical here. So for that we will understand our array first. So now we have requested the first address and 10 bits, means our data should be the first 8 bits, okay, and the next 2 bits, next byte will be worth 2 bits. So means this value is 51, byte should be value 1, means on the data 3 we should have the value 51, and on data 4 we should have the value 3, that is binary 3, okay. So let's check that. Here what we are doing is we are checking with respect to the input register whether if that bit is 1, we are also setting that respective bit in the data in, that is out register, as a pointer the value 1, else we are clearing that value. So I'll just go through the first bit is 1, we know that it is 1, so we should see here 1 on the data in 3. So it is 1, it is set. We know that second bit is also 1, so we should see the second bit is also set as 1. That is now like this way, the first bit is set 1, the second bit is also set 1, so we have the value 3 now. The third bit is 0, so the third and fourth bit is 0. So let's see how it responds. So the third bit is 0, so it is now clearing. If there is any value already here at that bit, it will be cleared. And also the fourth bit is 0, that is cleared again. Next comes the fifth bit. Now fifth and sixth bits are 1 1 again. So we should see the value change here. So it will change. So we have the value 19. So the fifth bit is 1, so that is 1. Fifth bit is 1, fourth and third bit is 0. second, and they are 1. So like this we have the value 19. Sixth bit is also 1, so the value 51 came. Let's see, I will also set the sixth bit here, so the value is 51. Okay, next 7th and 8th bit are 0. Since we have requested 10 bits, it will calculate till 10, so we are in the okay, so value is 0. Next the value is 0. Now when it goes to the 8th bit, here the address is 0, and with the calculation it will automatically check with the another index of the input array, and that is 1. So now it is 1. We should see here 1 in the fourth index of the data in array. Again, last bit we have to check, that is also is 4. So just as we discussed, it's the value should be 51 and 3. We have that. Next, the append to CRs, it is just same like the holding register which we saw, and also data sending to the Modbus master is also same. So now let's check it on the data on the Modbus master. So I'll just simply load the program. Okay, and instead of 10,001, now let's see, I want 10,005. Okay, and 10 registers accordingly. So I should have the register number 10,005 and 10,000 uh, 6 7 8 9 through 10,013. Instead of, I will request more. Okay, so here, though I am including many things, just for your understanding I will explain the starting, because understanding this intermediate is also very important, that I will try to tell you. Okay, I'll just click. Okay, we received the data. This data is in the form of bytes, so we have to verify with our, we'll verify with our data. Now here the 10,005 register number means the, we are starting with the fourth bit. Okay, so now here the fourth bit means it is within the 8 bits, so we'll consider this as the starting, the 0th index as the start address. Okay, now we have received the first one as 243. So now what does that mean is, we are checking with the fourth bit. Now this one is the fourth bit, 0 1 2 3. Okay, so we are ignoring these 3 bits first. So this is the significance what I wanted to explain you, that the bit number which we are requesting, we are fetching that bit positions only. So the first 4 bits are starting from the LSB, it is 1100. So here on the calculator also we received 1100, and the upper bytes, though it is in the same byte, it will fetch from, because Modbus protocol in the function code number 3, it is just concerned with the bits. It want bit number 0 1 2 3 4 5 6 7 8 9, like that. So we in the microcontroller have modified it, used it to suit our application accordingly, and we are sending the data as in the format requested by the Modbus master to it. So now here we have sent the first 4 bytes, that is starting from bit number 4, so address number 4, so address number 4 5 6 7 is sent. Okay, so now address number 8, so address number 8 will start from here. So since 4 bytes are only included, 4 more bits will be included in the same byte, so that is, in this way the value 243 is calculated in the first byte. Now the next 8 registers will again start from this, the remaining 4 bytes, that is 0010. Let's first open the, it is the value is 194. I will just put 194 and try to recalculate. So the lower bits 0100, it is same as here, the 0100, and next for the remaining 4 bits from the next byte, okay, that is starting from LSB 0011. So in this way the value 194 is also correct. So the similar approach is applied to the third one also, it is same. So in this way we completed the discrete input. We will simply copy it for function code number 1 also, and instead of discrete inputs we will say coils, and also we'll say here coils size. Okay, let me check the variables. Okay, the variable naming should match. Okay, I'll just build the project. Okay, so I made, actually I, the coils and discrete inputs has the same values, so it will be just same. Okay, I'll run the project. I'll set up the application for function code number 1. Say suppose I want to read 5. Okay, and I want to, the offset is 1. Okay, and I will receive it in 1 bit coil. Okay, let's see. So the same value. Okay, so in this way we have completed the major function codes read operation. Now by next week I'll try to demonstrate the write operations also. Write operations I would also like to share the misunderstanding that I would like to clear it with you next week. So see you, learn new things, and also like the video, subscribe and share it. Thank you very much guys.